Alright, so this question is, let f be the function given by f of x equals x to the third minus 5x squared plus 3x plus k, where k is constant. And part A is asking, on what intervals is f increasing, and identify the location of any extrema. So f is increasing when f prime is positive. So first of all, you need to find f prime. And you can find the derivative and get 3x squared minus 10x plus 3, which simplifies to 3x times x minus 3 minus x minus 3. And this simplifies to x minus 3 times 3x minus 1. And you want this to be greater than 0. And so once you factor, you get x equals 3 and x equals 1/3. And now you have to make a sign chart, and you can mark down that those two numbers are zeros. So if you take a value greater than 3 and plug it into the f prime equation, then you get a positive number, so you can put a plus sign on the right side. And if you take a value between 1/3 and 3 and do the same, then you get a negative number, so you can put a minus sign in the middle. And if you take a value less than 1/3 and do the same one more time, then you get a positive number, so you can put a plus sign on the left side. The intervals that are positive are the intervals that are increasing, so you can see that f is increasing on the intervals negative infinity to 1/3 and 3 to positive infinity. So to find any extrema, f prime must be equal to 0. From the previous part of this question, we know that the critical points are x equals 3 and x equals 1/3. Looking at the sign chart again, we can determine if the critical points are relative minimums or relative maximums. At x equals 3, the sign of f prime of x changes from negative to positive, and this indicates that this is a relative minimum. At x equals 1/3, the sign of f prime of x changes from positive to negative, which indicates that this is a relative maximum. So those are the two extrema. So for part B, it is asking, on what intervals is f concave downward, and identify any points of inflection. So we know that f is concave downward when f double prime is less than 0. So we need f double prime to be less than 0 here. So you can take your derivative that you found in the first part and get the derivative one more time, and you'll get 6x minus 10, which you have to make less than 0. So you'll get x is less than 5/3. And so this tells us that the concave downward is negative infinity to 5/3. We also know that f has points of inflection when f double prime is equal to 0 or when it does not exist, and f double prime must change signs. So you do the sign chart one more time, plug in a number greater than 5/3, and you get a positive number, so you put a plus sign on the right. And then if you plug in a number that is less than 5/3, you get a negative number, so you can put a minus on the left side. And once you plug in these numbers, you can see that 5/3 fit both of the criteria that I just described, and this tells you that x equals 5/3, which is a point of inflection. So part C is asking, find the value of k for which f has 11 as its relative minimum. And so in part A, we figured out that f has a relative minimum at x equals 3. And now all we need to do is plug in x equals 3 to the original f of x equation. And as you can see, I plugged in 3 to every x. And once I simplified it all out, I got x equals 20. And then when you plug in x equals 20 into the expression and you plug in x equals 3, you would get 11 as a relative minimum if you wanted to check your work. And then part D is asking, find where f of x has an absolute maximum and absolute minimum in the interval -1 to 5, and justify. So for this, you have to use the extreme value theorem, and this theorem states that absolute extrema of a function on a closed interval can only occur at critical points and or endpoints. And this question gives us the closed interval of -1 to 5. And as we figured out before, f of x has a relative maximum at x equals 1/3. And when you plug in 1/3 to the original f of x, you get 20.48. So f of x has a relative maximum of y equals 20.48 at x equals 1/3. And we also previously figured out that f of x has a relative minimum at x equals 3. When you plug in 3 to the original f of x, you get 11. So f of x has a relative minimum of y equals 3 at x equals 3. Y equals 11 at x equals 3. Next, you have to check the two endpoints, which are the two numbers in the interval. When you plug in -1, you get 11, and when you plug in 5, you get 35. The absolute maximum is y equals 35 at x equals 5, and the absolute minimum is y equals 11 at both x equals -1 and x equals 3, since they both have the same y value. Therefore, in the interval of -1 to 5, f of x has an absolute maximum of y equals 35 at x equals 5, and it has an absolute minimum of y equals 11 at both x equals -1 and x equals 3.